Hello all, let's start section 1.5. Section 1.5 is the limit of a function. As you see your canvas, I didn't put 1.4 for you. Actually, my plan is to talk about 1.4 and 1.5 together. What I am discussing right now with you, it covers your 1.4 and also it covers your 1.5. This is the first class of your calculus. Up to now, from section 1.1 to 1.3, what you studied in this class, it was not calculus, it was a review of your algebra class. Today, I will start the first lecture of calculus. Calculus has two main goals, or we can say why calculus. To answer why calculus, you should know that in calculus, we have two, let me change the color to black, two main goals, right? What are those goals? Or I can say calculus has two branches, correct? The main idea to study calculus, why we are studying calculus, our concern is two main goals. Number one, to find the tangent to a curve, or the tangent line to a curve. That's your goal number one. For example, let me explain. You have a curve like this, any curve. Let's say, for example, this curve. If I pick a point on this curve, for example, point A, and I want to find the slope of the curve at this point, based on the previous classes that you studied, it's not that easy to find the slope of a curve. Actually, by algebra, it's impossible to find the slope of a curve in a given point. Or if I draw here a line like this, which we call this line a tangent line, later I'll discuss it with you, what is tangent line. If I want to find the slope of this line, algebra can find the slope of this line at a given point. That's why we study calculus. Calculus gives us an idea to find the slope of a curve. As I discussed it before with you, when I'm talking about slope, it's not just about the slope of a line. Slope means rate of change. Later in chapter 2, 3, you will see that what is the meaning of slope and how we are using slope in different fields, right? That's why the idea of calculus came in. Maybe you are aware of the history of Sir Isaac Newton, the man who wrote calculus for us, right? The focus of Sir Isaac Newton was to find the slope, correct? Or I can say, maybe you saw this story before, that an object is falling down like this. Sir Isaac Newton knew that based on the algebra, he cannot find the speed of this object, for example, at a given time, like after 5 seconds or at 5 seconds, how much is the speed of this object that's going down. Maybe you saw this story, or maybe you saw this cartoon or picture of Sir Isaac Newton that he is sitting under a tree and an apple is falling down on the head of Sir Isaac Newton. I'm not sure it happened or not, but the main idea that he was thinking to find the instantaneous rate of change here. correct? That's why he worked on his math and he created calculus. That's the first branch. Our second concern or our second goal in calculus is to find the area under a curve. Maybe between 2 points. Between 2 points. That's the second part of calculus. I'll show you in a graph now. What does it mean? For example, you have this curve and you select 2 points on the curve, point A and point B. The second goal of the calculus or calculus gives you the power to calculate this area under the curve. How much is this area? With algebra, it's impossible. Or with geometry, or with trigonometry, the classes that you had before, it's impossible to find the area under a curve. But calculus gives you the power to can calculate the area under a curve, even the area between two curves, correct? We use a lot these topics in engineering. Later you will see in your calculus 1 or maybe in calculus 2, there are some constructions, some buildings, some famous buildings that they used calculus to design those, right? Right now, I want to tell you that the second objective of calculus is to find the area under the curve. A little bit about the history of calculus. Sir Isaac Newton was focused too much to find the rate of change or the slope of the tangent line in a curve. At the same time, there was another mathematician by name Leibniz. His focus was, or he was more interested to find the area under the curve, the second branch of calculus. Both of them, they were not aware of the work of each other. They were working at the same time on calculus. Even later, if you want to know a little bit about the history of calculus, there was a kind of tension between these two mathematicians. They were claiming that who first find calculus. But let me tell you that Sir Isaac Newton is a man that he actually published calculus book for the first time. Even I have the book. Let me turn on my camera. I can show you the book, his book. This is the book. This is the book that Sir Isaac Newton actually published. Correct? This is the first book. It's a part of it actually that I have, and the name is The Principle of Mathematical or Mathematical. It means the mathematical principles of natural philosophy. This is a little bit a short story about calculus. As I told you the first day of the class, that my goal is that you should pass this class and you should learn something also from this class. I cannot jump. I know other classes, they're already in 1.7, 1.8, they already finished limits, but I'm just starting limits. When I'm teaching you limits, first I give you the concept of the limit. Then rules are easy. You can learn rules in a few minutes, but the concept is very important. Anyway, that was the two main discussion in calculus. Now, chapter 1 and chapter 2 of your book, we cover the first part, which is we are dealing with the curves and the slope of the tangent line. We will study limits, then after limits, derivatives, correct? Maybe chapter 4 and 5, slowly, when you start integrals, then on that time we are dealing with the area under the curve. Let's start now with a problem that we call it the tangent problem or tangent problems. What is tangent problem? For example, you have a curve. This is a curve. Let me draw a curve for you like this. And you have a point given on this curve. Let's name this point P. This is x-axis. This is your y-axis. If I draw here a line that touches the curve only and only in one point. Hopefully you remember from your geometry or from your trigonometry, which is pre-calculus, what is tangent line? Tangent line is a line that touches the curve only and only in one point. Actually, they are saying touching the circle in one point. That circle is also a curve, right? Our goal is here to find the slope of this line at this given point. Using algebra, you know that it is impossible to find the slope of a line if you have only and only one point. To find the slope of any line, you need always two points. But here, I have only one line. Then, how to solve this problem? To solve this problem, I will I'll choose another point first. On my curve, I connect these 2 points with this blue line. Maybe I am using colors that you can see very well. We name this line secant line. The line that intersect a curve in 2 points, we call it a secant line. The red one is the tangent line. First, I'll name this point, for example, Q. Now, I have 2 points of a line. It's really easy to find the slope of this blue line, or I can call it the secant line, because I have 2 points. Using the slope formula, it's that you know from algebra, it's really easy to find the slope of the secant line. But my goal is to find the slope of the tangent line, not the secant line. Now, what should I do? Or if I ask you a question, unfortunately, it's not a face-to-face class, I cannot ask a lot of questions. Think how this blue line, secant line, can go closer and closer to the tangent line. The only way is to move point Q closer and closer and closer, very, very close to point P. And if I draw a line, this line is actually the same as tangent line. What I did, I moved point Q closer and closer and closer, really, really, let me use another word, really, 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 really close to point P. But remember, point P and point Q cannot be equal. You cannot bring point Q on the top of point P. And the reason is because you are looking for a slope of a line, you need 2 points, not 1 point. That's why you go really, 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 let me write. You go really, really, really close to P, to point P, but not equal to P. You're moving point Q really, 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 really close to point P. This gives you an estimation or approximation of the slope of the tangent line, correct? The idea that I'm using here really, 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 or we say point Q is approaching to point P. This really, really, really in mathematics, we call it limits. Okay? Or limit. This is the idea of the limit. You are moving a point in algebra really, really, really close, or your point approaching to another point really, really close. We call this idea in algebra or in calculus limits. Correct? Now, I'll do an example here for you. I'll show you that using the idea of the secant line, how you can find the slope of the tangent line. Then after that, I will discuss limits with you. Please watch this video carefully, even watch it few times, because today is the first lecture of calculus. If you get an idea what is calculus, what is limit, then next topic gets easier for you. But if you don't have any idea what is this, then you cannot memorize calculus. That's the bad part. That's why it gets difficult for you. Then please watch this video carefully. Example number 1. For example, they are asking you, find the equation of the tangent line find the equation of tangent line to y equal x squared at the point 1, 1. Great. Let me even draw the graph for you. Y equal x squared is a parabola because they asked me to find the slope of the tangent line at 1, 1. Even I don't need to draw the other part of the graph. I only need the positive part of the graph. I will draw just one side of the graph. The other side is like this, right? It's a parabola. This point is 1, 1. This is x, this is y. To find the slope of the tangent line, this line, let me draw here even a line for you. This is, for example, your tangent line that touches your curve at one point. I'm trying to find first the slope for this line. If I know the slope and one point on the line, based on algebra, it's really easy to write the equation of the tangent line. My goal or the problem is asking me to write the equation of the tangent line. You know that part is easy. You have a formula y minus y1 equal m times x minus x1. If I know the slope, of course I have x1 and y1. It's really easy to write the equation of the tangent line. But the problem is to first find the slope, right? To find the slope, I will choose another point on my curve. For example, here. Let's name, for example, this point P and this point Q. If I ask you, what is the coordinates of this point? In general, of course, it has an x value on the x. And how much is your y? Your y is x squared. You see here you have xy, it's a point. Let me write first, xy. But how much is y? Here, how much is y? Y equal x squared. It means your point is x and x squared, or x and f of x, which is x squared, right? Now look, I have 2 points. Using the slope formula, easily I can find the slope of the secant line, this line. And using the idea of limits later, or here I do a jump, but in future using the idea of limits, it's really easy to find the slope of the tangent line. Okay, I'm sure you remember the slope formula, the simple formula of the slope, which is m equals y2 minus y1 over x2 minus x1. Now I'll name the slope of secant line, m of secant, because first I want to find the slope of the secant line. Then the slope of the secant line equals, how much is your y2? Your y2, this one is your y2. This is y2, x2, y2. This is x1, y1. Correct? y2 minus y1, it means x squared minus 1 over x2 minus x1, which is x minus 1. Now, you see that here at this point, if I plug in the value of x in my slope, it gives me 1 squared minus 1 over 1 minus 1, correct? 1 minus 1 in denominator becomes 0, and any number over 0 is undefined. Then I cannot plug in the value of x, correct? The idea was to approach, to bring point Q closer to point P, or you can write as Q is approaching to P, the slope of the secant line actually goes close to the slope of the tangent line, because you are coming really close, correct? Now, look at here. M of secant line equals, using algebra techniques, can I factor the top? It's the difference of the squares, right? You can factor it as a x plus 1 times x minus 1 over x minus 1. Here, x minus 1 cancels out with x minus 1. Then the slope of the secant line equals x plus 1. Now, as Q is approaching to P, it means your x, here, look, let me make it smaller the page. As Q is going closer to P, it means your x is approaching to what? Closer to 1. As Q approaching to P, it means x is approaching to where? To 1. And if I plug in 1 here, it means the slope of the secant line becomes equal to. Let me do a jump here. You see the slope of the secant line is 2. When Q is going really close to P, it means the slope of your tangent line is what? 2. Here you go. Now you have the slope. You have the slope and 1 point on the graph. Isn't it easy to write the equation of the tangent line? It's a piece of cake now, right? What was our formula? Y minus y1 equals m times x minus x1. Y minus y1, your y1 was what? Equals m2 times x minus x1, x1 was 1. Distribute 2, y minus 1 equals to x minus 2. add 1 to both sides, then y equals 2x minus 1. This is the equation of the tangent line. Y equal to x minus 1. You see how much is your slope? Your slope is 2. And if I draw this line, immediately you will see this line will be the red line that passes or crosses only at one point. My graph is really bad. The red line should only touch at one point the graph, correct? And that will be the slope of the tangent line. This is the beginning or the idea how you can find the slope